Hey guys, we're going to look at writing linear equations based on slope or if we're given 2 points. So thanks for watching. Don't forget to like, comment, and subscribe. These are, well, this is, slope-intercept form of a line, which is really the main form of a line in terms of writing the equation out that we deal with. We don't particularly do a lot with standard form in this class, so in 1010 you do. But we're also going to introduce another form for you guys, so you'll have even another one to work with in your tool belt. Don't forget that the m is the slope and the b is the y-intercept. There's a little equation there for you. It's not necessary that you know that, but you could solve for the y-intercept taking a y value and subtracting the slope minus the x value that corresponds with it. It's just there in case you guys want it. Find the equation of the line with the slope of -11 and passing through the point 0.07. Okay. Well, we know the form of the line is y equals m, which is the slope, times x, and then we'll add in the y-intercept. In this case, they told us the slope was -11, so we can replace that in there right now as -11. And b is the y value in the y-intercept. This one gave us the y-intercept because the x value is 0. So we know that that is the y-intercept. And I'm just going to replace the b value then with 7. There it is. Slope-intercept form of that line. Find the equation of the line with slope. That's a weird slope, but that'll do. And passing through 0, -14, write the equation in slope-intercept form. So once again, we got this y equals the slope times the x plus the y-intercept, which is b. And once again, they gave us a slope, and that was extremely generous. So I'm just going to replace the slope m with the slope they gave us at 61/7. And then, yep, they did give us the y-intercept again. Don't expect this too often, but it will happen from time to time. And I'm going to replace b. I'm going to, instead of putting that as plus b, I'm going to make it a negative b, so -14. And that would be it. Well, that is slope-intercept form of a line, but this now is point-slope form. Now we know from slope-intercept form that they give us the slope and the y-intercept, which is why they call it slope-intercept form. This one is point-slope form, which means they're going to give us a point and the slope. However, it is possible that they don't need to give us the slope because we can find it as long as they give us 2 points to work with, right? We can use the formula for the slope or the rainbow method. Now this is point-slope form that I use. On the homework, just so you guys know, because if you type it in like this, they may mark it wrong, which kind of sucks. However, on the homework, they're going to show it like this one. Even on most videos you guys watch on this, they'll show it like this. Y minus y1 equals the slope multiplied by x minus that x1 value, which corresponds with that y value as well. Now some of you guys may look at this and wonder what the difference is. So you can see the y1 is on the left in this one that we just wrote, whereas the one that I use, it's plus y1. I just moved the y1 to the other side. This is going to save us a step if we memorize it like this. Just keep in mind again, I think on the homework they want to see it like this, which again kind of sucks. We use slope-intercept on this problem. Nope, we won't. We could, though. We could. Let's use point-slope form because we just went over it, though. Find the equation of the line with slope is 11, and passing through 520, write your equation in the form y equals mx plus b. Now this time we're not going to set it up like we did those first 2 problems. This one's going to work different because of point-slope form, which is, now that we have this, we can go into it and replace any values that we know. For example, the slope they gave us as 11. And then they gave us this ordered pair right here. Now this 5 is the x value and the 20 is the y value. which I'm going to replace as x1, which was 5 in that point. And the y1 is a positive 20, so I just keep it there as plus 20. If that 20 were negative, I would have that as minus 20. Or plus negative 20. It's going to be the same. Now this, if I remember right on the homework, is one of the answers. Except, again, they'll probably want that other form. However, what we really want is to figure out what this is in slope-intercept form. So we just need to simplify it. Because it's already a y equals stuff. So it'd be y equals, let's distribute the 11. 11 times x is 11x. Minus 11 times 5 is 55. Then we got that plus 20 right there. Notice it's already setting up in kind of in slope-intercept form because we got y equals 11x. We just got to combine negative 55 and 20, which is negative 35. And that is as far as I can simplify that thing. So that's my answer. Find the equation of the line with slope equals 4 and passing through the point, 833. We'll write the equation again in slope-intercept form. So we're going to use point-slope form because they gave us a point and the slope, point-slope form, okay? We know the slope on this thing. Now let's write it out first. So let's go ahead and replace those then. We know the slope is 4. And we'll replace the x and y values. The x value is 8 in that point. And the y value is 33. There we go. Point-slope form, which now, if we reduce this, will give us slope-intercept form. So we'll distribute the 4 again. I mean, this process really isn't going to change ever. 4 times x is 4x. 4 times 8 is 32, so minus 32. Plus that 33 right there. And y equals this stuff. So y equals 4x, but we'll combine our negative 32 plus 33, positive 1. And we did it. We find that some students have more problems with these types than we would expect. Okay? Now we do expect some problems because this is pretty new. But be careful on these because one of the problems some students have is that they've given us too many options on this thing. Not too little, even though we don't have all the information, not necessarily to start like we did before. What I mean by that is that we have to find the slope, all right? And once we do that, we'll use point-slope form to simplify this in a slope-intercept form. So you guys like the formula way, right? So it doesn't matter which one is which. I'm going to say that this is x1 and y1 over there. So I've got 9 and negative 7. And we'll say this is x2 and y2. So I've got 0 and negative 2 there. Simplified, this will give us the slope. Unless we do need to simplify it. Change that to plus. Negative 7 plus 2 is negative 5. That's kind of an ugly slope, but it's doable. Okay, well that is the slope. Now we're going to use point-slope form. Now we know we can change or exchange the slope with the slope that we have at negative 9/5. The problem is we sometimes find that we don't know which point to use. The truth is that it doesn't matter because they're all on the same line, and this is a straight line, so don't worry about it. You just choose whichever one you want. I am going to choose negative 2, 0 because it's got a 0. And working with 0 tends to be kind of convenient, okay? So I'm going to replace my x value and the y value in there. So my x value, I'll be careful on this one as well. I chose negative 2 as my x value, and we got to show it as negative 2. Because if we forget the negative, like the minus is the negative sign, then we've messed it up, all right? We don't want to do that. That's minus negative 2, and then plus the 0 there. Now, of course, this will change to plus, which is where sometimes the problems come in. To simplify this, we'll distribute the negative 9/5. Negative 9/5 times x is negative 9/5 x. Plus negative 9/5 times 2 would be negative 18/5. I'm just going to make that minus 18/5. So now we do have that plus 0. I like plus 0 because it's so easy. Anything plus 0 is itself, so I'm just going to make that a phantom 0. Done. Find the equation of the line through these 2 points in slope-intercept form. There we go. X1 and Y1. So I got negative 6 and 4 there. And we'll say this is X2 and Y2. So 5 and negative 7. All right, simplifying this would give us a slope. That's going to be plus 4 plus 7 is 11. And negative 6 minus 5 is negative 11. Yeah, that looks a lot better than what I had before. That's going to give us negative 1 right there as a slope. So in point slope form. And we do know the slope is negative 1. So that's pretty easy to deal with, except for maybe it's negative. And which point do you guys want? So we got an x value that's positive 5 and a y value that's negative 7. I'm going to make that a minus 7 right there because it's the same thing. 5 and negative 7. So let's distribute the negative 1. Negative 1x minus negative 1 times 5 is negative 5. Make that plus right there. And then minus that 7. So y equals this stuff. Y equals, some of you guys would rather look at that as negative x. And it doesn't matter to me. You can make that negative 1x if you want. Either way is good. 5 minus 7 is negative 2. That's it. This is a good problem for several different reasons. Let's look, okay? The slope formula, which you guys like. Again, we got this first point, which is at negative 8, negative 4. So my x value is negative 8. My y value is negative 4. And yeah, I understand I'm doing this while some of you guys have noticed something very peculiar about these 2 points. But I've got 0, 4 as my other point. So negative 4 on that one. We're going to change that to plus 4 right there. Negative 4 plus 4 is 0. And negative 8 minus 1, negative 8 minus 0 is negative 8. And 0 divided by negative 8 is 0. That is our slope, which we like. We do like that slope. So in point slope form, we now have a slope of 0, which we like. And we just got to choose which point we want to use in this point slope form. So which one do you guys want? So you chose 0, negative 4. And we'll distribute the 0 first. 0 times x is 0x. 0 times 0 is 0. So minus 0. Minus 4. Here's the great news on this is anything times 0 is 0. And 0 minus 0, if we combine these two, is 0. 0 minus 4 is negative 4. So we really just end up with y equals negative 4. Now, even though I've shown it like this, and this, if I remember right, this is the way that the homework wants it. If on a test you were to show that the slope is 0, that's okay. So if you made it 0x minus 4, I'm okay with this because it shows the slope instead of not showing the slope, which is what that first one is. But either are good. All right, there was something else about this, which you may or may not have noticed. We don't expect you to notice it because this is very new to us. Y equals mx plus b stuff. The reason I'm showing this is because we do know the slope. And as it turns out, we don't need to solve for the y-intercept because they gave it to us in this point where the x value was 0. So we would have known that we could have replaced b with negative 4. Again, that's very extreme, rare case of generosity that we math people show you guys, but it's not often that we give you the y-intercept in these types of equations, so expect to use point-slope form. Write the equation of this line shown, be sure to use the correct variable. Okay, well, slope-intercept form. Here's the nice thing about graphs, is when we look at graphs, we can find the y-intercept pretty quickly just by, again, looking at it. There it is, found it. Now, it may help us to see the actual coordinates of this point, 0, 5. So I know the y-intercept is at 0, 5, and I can fill that in. All I have to do at this point is figure out what the slope is. And if I use the stair step, I just need any 2 points. Already got 0, 5, so I'm just going to use 10, 5 right there. 10, 5. And my slope. How far up is that stair step? 0. How far to the right? 10. That's 0. So my slope is 0. 0x plus 5. Again, they're kind of looking for this y equals 5 business. But I'm okay with either. Write the equation of the line shown. Be sure to use the correct variable, just like the last one, which again is just going to be slope-intercept form. Now some of you guys notice this line is a little different than what we're used to seeing. But we have seen this type of line before. The y-intercept. Now we should think about this. Okay, where is the y-intercept? Well, we don't see it, but then the question becomes, will there ever be one? Well, this y-axis is parallel with that line, so there is none. Oh, what the crap does that mean? Well, it means that we have this in the wrong form, right? So what I mean by that is, look here. So we've got this point here at 10, 0. And then we've got to choose any other point. Let's choose this point. 10, negative 8. Right there. Now, if I found this using the stair-step method, I would take my slope, right? And how far up do I go right there? 8. And then how far to the right or left? 0. Well, anything divided by 0 is undefined. So what this means is that we can't use slope-intercept form. But what this does also tell us is that the x value is 10 and the x value is 10. Not only those 2 points, but everywhere else on this line, it's 10. So the equation for this is x equals 10. Done. Because x is always going to be 10, no matter what the y value is. That's pretty nice. Consider this equation. Write the above equation in the form y equals mx plus b, whose integers are reduced fractions. So no mixed numbers, which we hate. I think we did something like this last time. This is just equation manipulation, specifically for y. So we're going to solve this equation for y, and whatever that comes out to be will be our slope-intercept form. So if I were to do this one then, I would need to get rid of that negative 10x. So I'm going to isolate my y's. I'm going to add 10x to both sides. And I will switch that 10x and the 5 right now. Both positive, so that's good. And then finally we'll divide both, well, all the terms by 4. So y equals, that's a 1y, which is what we want. 10 over 4, that can be simplified into 5 halves. And then plus 5 fourths. We did it. We got the slope and the y-intercept on this. Now that y-intercept is a fraction, which would be kind of difficult to graph, but we're not worried about that right now. Write an equation for this line parallel to and passing through, parallel to that equation and passing through that point. Okay. So let's take that original equation, 7x plus y equals negative 7. And we'll manipulate this equation for y, which isn't too hard. This one's just going to subtract 7x from both sides. So that gives us y equals, I'm going to make that a negative 7x, and then minus that 7 right there. So I just flopped or switched these. Well, why did I do that? Because I need the slope. And we're looking for a line that's parallel to it. So I know that just setting this up, my slope of the new line that's parallel to it is going to have the same slope, -7. However, they gave us a point, so I have the slope, and I have a point, which means I should be using point-slope form. Now this one's kind of nice. I mean, yeah, we do have the slope already at -7. But we don't have to choose between points this time, so no confusion on that. We have an x and y value on this. The x value is 1, and the y value is -16. So we'll fill those in. Now we'll distribute the -7. -7x minus -7 minus 16. So y equals -7x, and we'll combine our like terms there. That's going to be plus right there, by the way. 7 minus 16, -9. And we did it. We found the equation of a line that's parallel to 7x plus y equals -7, and it also goes through the point 1, -16. Write the equation of a line that's perpendicular to this one and passes through that point. Same idea on this one. I'm going to manipulate that equation until I have y equals something. And again, that's just specifically to find the slope of that line. We're going to add 11x to both sides. Again, the only reason, we don't really need that -6 there. We just want the coefficient of x, which in this case is 11. And that is the slope. And that will be the slope in the new line as well. No, I take that back. This is perpendicular. So, right now the slope is 11 over 1, and I am showing this as a fraction because we need to reciprocate it, and also take the opposite of it, so it's going to be 1 over 11. There we go. So this is the slope of the perpendicular line, -1/11, and I'll fill that in my equation right now. All right, let's fill in our x and y value, which again, we only have one point to work with on this. This equation has to go through that point -14, +2 right there. Now whether you do it now or later, we can change that to +14. And we'll distribute the -11 into the parentheses. I'm sorry, -1/11. -1/11 times x is -1/11 x. And then we'll make that plus -1/11 times 14 would be -14/11. And yeah, I can change that to minus right there now. Right there. And we got to add that to 2. So y equals this stuff. Now we got to be careful when we add that 2 right there because they don't have common denominators right now. Right now the 2 has a denominator of 1. So to change that into a common denominator, I'm going to have to multiply the denominator by 11 and the numerator. So that gives me a new fraction. There we go. And that is positive. Nothing else changed on that. And now that we have common denominators, we can simplify that. Yes, you could do that with a calculator, but whatever, all right? Y equals -1/11 x. Then that'll be in the 11ths there. It's positive 8/11. We did it.